an educator at tree level by Unacademy. Today we are going to solve a very exciting problem, that is pyramid scheme. So I will take you through its problem statement and then we will be looking into its logic, and later on we are going to do its implementation in JavaScript. So I hope you will find it interesting. So let's get started. So the problem statement is there is a pyramid scheme consisting of n brokers. The company has decided to give bonuses to all the brokers in the scheme who have some number of brokers under them in the pyramid. One is the founder of the scheme, so all the brokers are under him in the pyramid. So what it is actually saying, so you people must have heard of real time, some people are actually doing these things, right? So they actually say, okay, I have these many peoples under me, and I really need to have some target and everything. So that is how they actually do all the chaining thing. And I will not be naming, but I have heard quite a lot about these things. So it is saying that whosoever is going to be under them, they are going to get some bonus. So what we actually have to tell, who and all are actually going to be under whom. So that is what we have to find out in this particular question. So I will be opening my scribbling pad and then we will be working into it. So it is pyramid scheme. Alright, so in this particular one, what is going to be there? We are going to have some tree. So I'll actually take the tree which is given to us like that. It was there. 2, 4 and 5. So if you will actually see who and all are under one we have 2, 3, 4, 5. I'm not putting it into the same order, I'm just putting it in any order, okay? Now how many people are under 3? So that is 2, 4 and 5. How many people are under 2? So no one. How many people are under 4? We have 5. How many people are there under 5? Answer is no one. So this is how we have the problem statement given to us in this question. Now what we will actually observe, what this question is actually asking us to do. So this one is basically asking us to do the subtree of all the nodes in the tree using DFS. So that one we are going to do now. Subtree, like I'm just, whenever these people ask questions, you always have to see if that is actually relatable to something which we have already done. So in this particular one, what is the thing which we are actually going to use? That is the subtree of all the nodes using DFS. Okay, what is DFS? DFS is depth first search. So it is going to be subtree of all nodes in a tree using DFS. Okay, so in this, what is actually going to be given to us? So they are going to give n number of nodes of a tree and their connections. So in this particular one, they said that A is the owner. So that is how they are going to give us some tree. In this particular one, these were the total number of nodes. So obviously, even if we have to draw it, we will be having the exact number of all the nodes here, right? So what we can say in this one, what and all things which is given to us. So given n nodes of a tree and their connection. You have to print subtree nodes of every node. Okay.
कुछ पैसा लेके आना है सब.
And what is a subtree? So in this particular case, what is a subtree? So here you are assuming a right child. If instead of child, we have another tree here. So that one we refer as subtree. So one is not having any left subtree, but it is having a right subtree. If we will come to 3, so 3 is not having any, 3 is having left child, not a left subtree. And it is having a right subtree. So that is how we actually define subtrees. Okay. So what is a subtree? Subtree of a node is defined as a tree
अच्छा,
which is a child of a node. Okay, in this, what we are putting emphasis on, so we are actually putting emphasis on the word child, but what is actually going to be the child? So child is actually going to be the descendant of a tree node. So if we are talking about this, so what and all things are going to be under it? So if we are referring about the left descendant, so it is going to tell about the left part. Right one is going to tell me about the right part. But what you will have to keep in your mind that it is asking about the descendant. We can actually write like descendants of a tree node. Okay, and obviously if we are going to consider it, it is also going to be the subset of the larger tree, but when we are going to print it, we'll have to keep it in our mind that, like, let us say I want to print the brokers which are there under 1. So at that time we'll have to ensure that when we are going to list it down, we are not going to cover each and everything there. So now what I will be doing, like, what is the approach which we are going to use in this particular one? So we'll have to be clear about the approach, and then only we should be moving ahead. So I will be telling you about it in detail before jumping into the implementation. Okay, so what is the approach?
ऑरेंज पहन के मरिया
So they are saying that you have to do the DFS reversal of all the nodes. So with the DFS, what we actually do, so this is actually asking you to print each and everything under that. So if you are going to perform the DFS from that particular node, so like let us say if you are going to do it from this particular node, you will actually end up getting all these. If you are doing it for this, you will actually end up getting all these things, right? So what we can do, we can say you have to do DFS reversal for every node and print all the nodes which are reachable from a particular node. Okay, so that is what I was referring when I was showing you that what we are actually doing, we are reaching to a point, and then with the help of DFS we are checking what and all nodes are going to be there. And why are we using this term reachable? So we should be having nodes which are reachable from the given node. So that is the one condition which is given to us. Now what I will be doing, I will be telling you some of the explanation before jumping into the code. Okay, so in this particular one, what and all you have to do, so when your function, we are going to create a function DFS. So we are going to say when function DFS, and that one we are going to start from 0, that is going to be the start node, right? When this function is going to get called, what you will have to do, you have to start it from 0, right? Start 0 is going to be 0 because we are starting it from 0, so it has to have that one as the start node. After that, what you will have to do in such a case, you have to push the node 0 and you have to mark this one as visited to keep the track of visited nodes. So what you will be doing in such a case, mark the node as visited to keep a track of DFS order. Okay, so this is one of the thing which you will have to do. After that, what you will have to do, you have to consider the adjacency list. And why are we considering the adjacency list? That is because, let us say you are at one point, you have to look into the adjacency values or the nodes there, right? So what you will be doing, now consider adjacency list. And when we are going to consider it, what you will have to consider that it is a directional path, because if we are not considering it as a directional part, we can actually look into the up direction as well. But do we have to look into the root or anything? No. Do we have to go to the parent or or the ancestors? No, we have to look only into the child ones. Okay, so when we are going to consider the adjacency list, what we will have to do, we'll have to consider that uh, as considering directional path elements and those ones which are connected with the root node which we have just considered as the start node, right? Not exactly root node, the start node which we have just considered. Okay, so directional path elements connected to node 0. So here by 0, like you do not have to get confused that okay, in the given question there was no 0, but by the term 0 I am actually referring to the starting node. Okay, and that will be in adjacency list, because now we are actually looking into the its adjacents, right? That will be in adjacency list corresponding to 0. After that, what you will have to do, like once you are getting the adjacency list, now what should be the first next thing? That one should be that now you are recursively calling the DFS function, because after reaching to that node, what you will have to do, you will have to look for the we will have to recursively look for the DFS, and how DFS is going to happen first on one depth level, then it is going to go to the next one, and so on until we are reaching to the leaf nodes, right? So what we can say now recursively call DFS function till all elements are traversed. That is what we want to do, right? After that, what you will have to do, you will have to look if, like, let us say we are at one element. So what we will have to do, we'll have to look for its adjacents. If in such a case, like let us say if something is already called and for that one the element is already traversed, so we are not going to consider it. In such a case, we are going to consider the only ones which is not yet considered. Okay, because we do not want to have the repetitive nodes. Also, like if we are going to do it in the similar form, we can actually get all our nodes traversed and we can store the DFS order in order to find subtree of that particular node. So what we can say, now after this when we will be moving into its implementation, you will actually be able to relate to it. So what we can do, similarly, all nodes will get traversed and they are actually going to store DFS order in array to find subtree of nodes. So even if you're not able to relate to whatever theory which we have done so far, but I will say just be patient. I will be moving into its implementation now, and after that it will actually get clearer. Okay, so I will be opening my Visual Studio Code. You can use anything. I use Visual Studio Code for writing the code. In this one, what we are first of all going to do, we need to have something in which we are going to like we need to actually have some array where we actually have to keep a track of all the starting and ending points for the DFS traversal. So what I will do, I'll create one array that is going to be start, and this one I'm going to initialize to some value, like some random value I am taking. You can take anything, and similarly I'm going to create some end array. After this, what do you have to do? You have to store the DFS order as it is asked in the question. So, storing DFS order. So, if we'll have to store the DFS order, what we will be doing, we are going to create another array. So, let DFS order, okay? Right now I'm just taking it as empty array. Later on, whenever we are going to find any values, we are just going to pass it on here. Okay, and we are going to create one adjacency list in order to look into all the adjacent nodes in the tree. So through this we are creating one adjacency list. Now after that, what we will have to do for all the values, array values, what we will be doing, we are just going to just iterate over it, and we are going to push it to our adjacency list. So we are going to start from let I 0 up to this, and what we will be doing in the adjacency, we are going to push the empty array. Okay, for now. Later on, what we are going to do, we are going to create something for the visited. And why are we keeping visited? If you remember the exact DFS as well, there also we keep a track of the visited nodes. So through that we actually come to know that okay, these many nodes are already visited and these ones which we have to visit. Okay, so let visited. Okay, in this particular one, again we are going to define an array of the same size. After that, what we are going to do, initially we just want to initialize it to false. So one way is either we can do fill here only, otherwise we can do fill on the next line, like up to you, how do you want to fill. So what fill is actually going to do, it is going to put all the values in this array as the given value. So here I'm providing false. So what it is going to do, in the visited array, everything is going to get set to false, and later on when we are visiting something, then only we are going to mark this as true. Otherwise it is going to remain false. After that, what we are going to do, we want to create some function which is going to recursively perform the DFS, right? So we can say some DFS. You can actually give it some other name as well. Not DFS order. We can take this. And here I can provide A and B. Okay, in this one, what we are going to do, first of all, we have to keep a track of all the visited nodes. So keep track of node visited. And how we can do, if we are visiting some node, what we are going to do for that particular one, we have to mark that as true. And then for the B, we are going to do +1. Why are we doing +1? That is because after visiting it, now we have to move to the another one, right? So that is what we are going to do. Now with this A and B, I am going to update the start. So in start A, I am going to put B. So what this means, we started from A and now we are at B. So that is how we are linking it with each other. Now in the DFS order, what I will be doing, I will be pushing this value of A, because this one is a part of the subtree, right? Later on, what we will have to do, we have to iterate it, right? So we are going to iterate over, let us say, from I to whatever the adjacency list which we have just for the A node. We do not have to run it for everything, we just have to do it only for the A node. So whatever the length for that is going to be there. After that, what we are going to do, we will just first of all be checking if it is already visited or not. If it is already visited, no point of visiting it again, right? So we are going to check it in adjacency list for your A and B, and then we are going to check it like for your A and B, we are going to check. After that, if it is already visited, what you will be doing, you are going to call B, and in this B we are going to call the DFS of this particular node. So if it is not visited, in such a case we have to visit, right? And when we have to visit, we have to provide two parameters. So what is going to be the first one? That is going to be this. So we are going to pass this adjacency, and here it is going to be I, not B. Here also it is going to be I. So we are going to test it against this and the B, which we already have in the question. After this, what we are going to do, since it is already visited, we can actually mark this one as the end, right? So after coming out of the for loop, so what we are going to do, we are going to update our end, and to the end we are going to provide B. What does this mean? It means we started from A, now we have reached to the end, and now we do not want to do anything. And later on, what we are going to do, we are going to return B from there. Later on, we even want to print all the values. So what we are going to do for the printing of the values, we are going to create a function for that. Okay. So let us say we have something like let print, and here we are passing values in. So in this, we are going to take one string, because if you will just console log, everything is going to come in the different order. If you want to print it in one order, best way is to use string. Okay. Then here I am actually starting it from 1. Why I am starting it from 1? Why not from 0? That is because I do not want to include the parent one. I just want to include the child nodes, or the nodes which are below to the given node. That is how I want the output for the given question. Accordingly, like whatever the question is given to you, accordingly you will have to make these changes. Okay. So inside this, I am going to initialize it to empty string. Why I'm doing it here, why I'm not doing it outside? That is because after printing it for one particular node, now I want it to get reinitialized. Otherwise, what is going to happen? It is going to append all the values, and that is something which we do not want. Okay. So now what we want to do, if a node is a leaf node, so what we are going to do, so if node is a leaf node, then start I is actually going to be equal to your end, because if it is a leaf node, we are not going to have anything else, right? So in such a case, what we are going to do, we are just going to check if that is a leaf node. We do not want to do anything, right, in such a case. So what we are going to check, we are just checking if it is not a leaf node, means if it is not going to be equal to each other, then only we are going to make all the changes. So what we are going to do, we are going to update our string which we have in this. What I am going to write, subtree or brokers under, and here I can actually provide I. That one is going to provide the broker number, and then I can say R. Okay, and remaining values I'm going to get it from the another loop. So for that I am going to start it with J. That one is going to start from start I plus 1, and then we are going to have end I plus 1, and then J plus plus. So what we are actually doing, we are just iterating over all the values which are going to be under that. So what we are going to do, when we are going to come here, we are just going to take the values from the DFS order, and after taking the values, like I'm taking it from the previous one because that is how we want the values to be there, right? And after taking all the values, I'm just making them space separated. And at the end, what do we have to do? Just you have to console it out. So in this, what is going to happen? All the values, if it is not a leaf node, it is going to print. Like if you want to print it outside as well, you can probably put some condition that if it is still empty, how you are actually handling it. But this one is going to store all the values. Like firstly, we will be achieving what is the desired one, and later on we are going to modify it. So now what I'm going to do, I will be defining some n, and that n, like for now I'm just taking 10, some random number, and I'm taking C as 0. So C is going to this n is actually going to help you if you want to provide the nodes. And now if we will come here, so how we had the values 1, after that 3, 2, 4, 5, like that we had all the values, right? So now we are going to add it in the same order. Okay, so how we are going to do in the adjacency at 0, what we want to do, we want to push 1, because in the beginning, after like the First one should be 1, right? After that, what we want to do at 1, what is the next node which we want to have here? That is going to be 3. After 3, what do we want? 2 and 5, 2 and 4, right? So what do we want to do here? After 1, what do we want? 3. After 3, what do we want? 4 and 5. I will be just copy pasting it. First we had 2, then we had 4, right? And then after 4, what we have? 5. So like this, we have actually seeded all the values in our tree. After that, what do we have to do? We have to just call our DFS, right? So if we want to call our DFS, what we will be doing, we are going to call it with 0 and C. C is actually going to have the root node at C. That is how we are passing it on here. And after this, what do we want to do? We just want to print all the values, right? So in order to print all the values, we are just going to pass on our N there. Now let me run and see the output for the same. So you can see, if we will come back here, you can see what all are the brokers under 1, 3, 2, 4, 5. What all are the brokers under 3, 2, 4 and 5. Under 4 we have 5. So if you will come here, you can see under 1 we got these. Under 3 we got these. Under 4 we got this. Now if you want, like, you can actually say that for the rest ones it actually didn't print. If you really want to print even for the other ones, what you can do, this one, instead of doing it here, you can do here. So you can actually initialize it from here, okay? And what I can do, probably we can take some flag. Let us say let flag is 0, okay? So here, if we are ever entering inside F, we are going to set it to 1. And this one we are going to reinitialize it here. So what is going to happen? Initially it is going to be 0. If we are entering inside F, we are updating it to 1. And later on, you know what we can do? We can just check here if your flag is 0. In such a case, we are going to print it into another form. Otherwise, we can just print this. If flag is 0, we can just print what we can do. To this, we can write no brokers, something like that we can do. And this one we can actually make it common. So now if you will run, you can see it has actually printed for all the nodes. And why it is actually running it like this? Because I took the value as 10. If I want, I can actually take it up to 5, and then in that case it is going to work fine, because it was actually saying that you have to take the number of nodes. So now accordingly, if you will see, it is printing it in the correct order. So under 1, it is showing number of brokers. Then under 2, no brokers. Under 3, it is showing brokers. And here, if we'll make it equal to n, now it is even going to show under 5. So under 5, we do not have any brokers. If we will come here, so that is what was actually desired out of it. So that is what they were expecting. So with the help of that, you can actually tell, okay, these are the brokers. If these are the brokers, so then only we will be eligible for providing them some bonus. So this is what this question was all about. I hope I was able to make it interesting for you. All right then, we'll meet in next class. Bye bye.